Hello everyone, and thank you for being here. My name is Dan Smedescu, and I'll be presenting joint work with my colleagues from the Romanian American University, Negricea, Ionescu, and Iordache. Our paper looks at road construction companies from Romania and asks a practical question. Can AI-driven automation help these firms improve their financial performance? I will first show how we classified 179 companies by financial performance using discriminant analysis and the neural network, and then present two concrete N8N automations we propose for the weak performers. So why now? Well, Romania is going through its most intense period of road construction in its history. The motorway network reached around 1,200 kilometers at the end of 2025, with 131 kilometers added in 1 year alone. Obviously, a large part of this is financed through the National Recovery and Resilience Plan, around 20 billion euros in total, with transport as the largest component. At the same time, road transport carries more than 3/4 of inland freight in the EU, and the TEN-T deadlines put road infrastructure at the center of the cohesion agenda. So, the companies in NACE Code 4211, road and motorway construction, face unprecedented demand. The question is whether they are financially equipped to absorb it. Our objective is twofold. First, a diagnostic part. We want to understand how the companies in this sector rank in terms of economic and financial performance using their official accounting data. Second, a prescriptive part. For the firms that underperform, we propose concrete AI-based marketing automations as a recovery direction. This translates into two research questions. Research question 1, how can these companies be ranked by financial performance? And research question 2, how can marketing automations be used to improve their activity? Now for the data. We looked at the entire NACE 4211 sector, construction of roads, motorways, streets, airport runways, and accessways, and selected all companies with more than 50 employees. That gives a sample of 179 firms. From the balance sheet they filed with the National Fiscal Authority, for 2024 we computed 7 indicators, 3 profitability ratios, profitability of sales, gross margin and return on expenses, and 4 structural ratios: the debt ratio, the receivables ratio, the inventory ratio, and the receivables recovery period in days. Keep an eye on this last one, I7. It will turn out to be central to the story. Our methodology has 5 steps. Step 1. We compute the 7 performance ratios for each firm. Step 2. We form an initial classification based simply on company size. 28 companies with more than 250 employees, 79 with between 100 and 250, and 72 with between 50 and 100 employees. We chose this split because year-on-year comparisons showed that quite a few companies had scaled back their operations. Step 3. Discriminant analysis reassigns firms to classes based on their actual financial indicators, not their size. Step 4. We train a multi-layer perceptron to reduce the classification error further. And step 5. For the class with weaker performance, we propose marketing and communication automations as a recovery direction. First results. The MANOVA tests, Wilks, Lambda, and its companions reject the null hypothesis that the indicators have no effect on class membership, so the discriminant analysis is statistically justified. The interesting part is what happens when we reclassify. Starting from size-based classes, the discriminant analysis moves a lot of firms around. Class 1 grows from 28 to 50, Class 2 stays roughly stable at 75, and Class 3 shrinks from 72 to 54. In other words, a company size is a poor proxy for financial performance. Many smaller firms have profiles much closer to the top class. To further reduce the classification error, we train the feed-forward multi-layer perceptron. It has 7 input neurons, 1 per indicator. 4 hidden neurons with a hyperbolic tangent activation, and 3 probabilistic outputs, 1 per class, trained with backpropagation. The chart shows the error evolution from roughly 0.15 on the training set and 0.13 on validation down to about 0.079 and 0.085 after 110 iterations, a reduction of 49 and 38% respectively. The two curves move together, which indicates the objective of the classification error has been reached. After this refinement, a few more firms migrate. The final composition is 75 firms in Class 1, 73 in Class 2, and 49 in Class 3. This answers the first research question. We now have a robust performance hierarchy. So how does the trained network actually score a company? These are the transfer functions we extracted from the trained network. The model is fully transparent, not a black box. Equations 9 through 12 form the hidden layer. Each hidden neuron H1 to H4 is a weighted sum of the 7 indicators I1 to I7, with the weights shown here fixed after training. Equations 13 to 15 then combine the 4 hidden neurons into 3 class scores, and each company is simply assigned to the class with the highest score. The practical value is that any company, including one outside our sample, can be scored directly by plugging its 7 indicator values into these equations with no retraining needed. This slide brings the whole reclassification story together. We started simply by employee size. Then the discriminant analysis shuffled firms around, mostly from class 3 to class 1. And then the multi-layer perceptron neural network refined the result. We can see that the discriminant analysis did the heavy lifting and the neural network did the fine-tuning. So how can these 3 classes be defined? Class 3 contains the star performers on paper at least. Profitability around 3 times higher than class 1. But this comes bundled with an 82% debt ratio and critically 309 days to collect the receivables. Excellent economics, fragile liquidity. Class 1 is the balanced group. Moderate but steady profitability, strong inventories, and the most efficient receivables collection at 107 days. And Class 2, the largest group, 73 firms, is the problem. Negative profitability across all 3 ratios and 44% of assets locked in receivables. Notice the common thread across all classes: receivables, I7. Even the best performers wait months to get paid. This is exactly where our proposals aim. And this brings us to research question 2. For the underperforming firms, we designed 2 marketing automations on the N8N platform, an open source workflow tool that connects advertising platforms, CRMs, AI models, emails, and social channels. The key design principle: these are not social media for its own sake. Each automation is built to shorten the cash cycle, from lead to contract to invoice to payment, because receivables turned out to be the sector's structural weakness. Let me walk you through both. Proposal 1, lead management. Today, leads from Facebook and Google ads are picked up manually, evaluated inconsistently, and reach the sales team late. Facebook produces volume but variable quality. Google captures explicit intent at higher cost. The N8N workflow captures leads from both platforms, normalizes and cleans the data, assigns a unique lead ID, and applies scoring rules based on client type, estimated project value, location, start date, and data completeness. Premium leads go straight to sales via Slack, standard leads enter nurturing, and rejected leads are archived without consuming commercial resources. Everything is logged in Google Sheets and created in Zoho CRM. The financial logic: a poorly qualified lead often becomes a client who is hard to invoice and slow to pay. Filtering at the top of the funnel reduces overdue receivables downstream. Proposal 2 closes the loop. When a job is marked as finished, a webhook fires with the client's data. The workflow automatically sends a feedback request and, applying the same principle to finance, the invoice, the acceptance report, and a payment link can go out immediately, followed by scheduled reminders before and after the due date. If the client doesn't confirm receipt or doesn't pay, the system escalates to accounting or the project manager. This eliminates the dead time between finishing a job and starting collection, which today depends on someone remembering to follow up. For firms carrying heavy costs for materials, subcontractors, and equipment, converting finished work into cash faster is a direct improvement to the cash flow. And now to put it together. Each automation targets specific indicators. Lead scoring, the first automation, shortens the sales to invoice cycle and improves profitability by keeping bad projects out of the pipeline. Completion follow-up, the second automation, attacks the receivables recovery period directly. The indicator where even the best class waits over 100 days and class 3 waits 309. The common denominator is I7, days to collect. The effects are indirect and build over the medium term, but they connect online promotion, sales, and finance into a single data-driven process. To conclude, on research question 1, combining discriminant analysis with a neural network gave us a robust 3-class performance hierarchy of the 179 firms and showed that company size alone is a poor predictor of financial health. The diagnosis revealed receivables as the sector's structural weakness. Even the most profitable firms wait months to collect. On research question 2, we proposed 2 N8N automations that connect marketing, operations, and finance into one process, scoring leads before they become bad debtors and making job completion trigger the collection process. As next steps, we plan pilot implementations in Class 2 firms and the longitudinal measurement of the indicators, especially the receivables recovery period. Thank you very much for your attention. If you have any kind of questions regarding the classification methodology, the indicator set, the practical side of implementing the N8N workflows, or any other questions related to the article, please reach out via email. Wishing you a successful and productive conference.